So you're cooling your PC. What key components do you need to cool and why?
Hi, I'm Paul, this is Diane, and we are the PC Zombies, and this is the second segment in PC Cooling Basics.
In our last video, we found out that water cools more effectively than air.
And now we're going to tell you which components need to be cooled and why. Let's get going.
All right. Okay, how do you cool a PC?
Okay, we're talking about PCs, but let's actually focus in on one part of the PC. The thing that you need to cool the most in your PC is your CPU. If you're running a really fancy high-end graphics card, that's the second most important thing, or maybe even the more important thing, because those can be very, very expensive. A high-end CPU, like in the PC we're building right now, is something around, $750 for that CPU. The graphics card in that PC is $2,500.
Well,
that's a whole lot more.
Well, why wouldn't you cool the graphics card first if it's more expensive?
You kind of want to cool everything, right?
Okay.
But graphics cards, it turns out, come with fans on top of them already.
Oh.
So they're already ready to be cooled to a temperature that they can operate at. Your CPU does not come with any fan. You have to put one on it. So when you're buying a PC, it comes with one built in, obviously. But if you're building your own PC, you need to choose, do I want to air cool it or water cool it? On average, a CPU runs at 40 or 50 degrees Celsius. A CPU can get as hot as 100 degrees, which is about 212 degrees Fahrenheit for those of you in America. Did you see how I did that?
Yeah, I did.
When we talk about PCs, we always talk in Celsius. When we talk about anything else in America, we only talk in terms of Fahrenheit.
That's strange.
If you're running a game or some tough process, that CPU is going to start to get hot. Then it starts to break down. It's not good for a CPU to run that hot. And the reason why is the way CPUs work today is you supply power to the CPU, and that determines how fast they operate. If you're just doing spreadsheets or internet, they don't need to run so fast. But when you're playing a game or doing video editing or some of these really tough tasks, the CPU needs to start going really fast. And at that point, it gives it more electricity, which makes it run faster, but electricity creates more heat. It creates heat in multiple places. There's a thing called VRMs that help to provide the power from the motherboard to the CPU. The VRMs get really hot. Then the CPU gets really hot. You gotta get that heat away from that CPU to keep running that process as fast as you wanna go.
Sounds like it'd be a great heater for the winter.
And some PCs used to be, I remember back our old PC, I used to turn it on in the morning and my office would be nice and toasty in the middle of the winter time in about 10 minutes. Nice. I don't think they're that inefficient anymore. But you don't have to worry about the CPU going to 100 degrees Celsius because the CPU has a built-in thing called thermal throttling.
What is thermal throttling?
Thermal throttling is when the CPU detects it's getting too hot, it suddenly says, especially there's different cores in the CPU, it starts giving those cores less electricity, therefore slowing them down and then releasing less heat. And so the CPU automatically slows itself down to prevent it from overheating. Because CPUs are expensive and they actually are smart enough, they can decide what they need and what they take.
They say it's the brains of the computer, right?
It is. They are the brains of the computer. And you're the brains of the outfit, aren't you? So now you know what needs to be cooled. Next time, we're going to talk about air coolers.
We love the feedback, so thumbs up and please subscribe.
Thanks, guys. Bye.
Bye.